So as we have discussed about the intermediates, that we have already discussed that what is the free radical, how we can explain its stability and which free radical is actually stable. So now we will look for the another intermediate, that is the carbocation, right. As the name suggests, it is a carbon with a positive charge, right. So carbocation is a carbon which has the positive charge on it, right. Positive charge means it is deprived of electrons. So we can say it has actually a 6 set of electrons. That means it has only 6 electrons in its valence shell, and that means it is obviously if it has less number of electrons, so it will have a love for the electrons, right. So that will take up again in a different topic. So as far as we are concerned with the intermediates, so we can get definitely a carbon with a positive charge, and that is called as carbocation. And how the carbocation is formed? It is formed as a result of heterolytic fission. I told you that the one which takes away the shared pair acquires a negative charge, that is something carboanion, we will discuss later, and the one which has a positive charge is a carbocation. So this is how actually it is formed. So now if we talk about its stability, so it can be actually explained. So let's see first the order of the stability. 3 degrees more stable, 2 degrees less stable, 1 degree is less stable, and methyl is least stable. We are talking of the carbocations here. So now we have to discuss about the stability, why the order is given in such a order, right. So it's that we can actually explain on the basis of inductive effect and also on the basis of hyperconjugation. You know, you are very well aware of the electron displacements, that is the inductive effect, which comes into play when some electronegative element is there, right. And depending upon that, we have the atoms which are less electronegative than the hydrogen, we have the atoms which are more electronegative than the hydrogen, showing the minus I and the plus I effect, we know that. And here the hyperconjugation, we know that also it is the no bond resonance. So let's look at the board, that how they actually able to explain the stability. So now what happens if you take 3 degree, it will be something like that. It will be something like that. So now what happens in 3 degree, what we get to see is that here there are lot of, so that means here it will have a positive charge, here it will have a positive charge, right. So what happens, there are these alkyl groups which are being attached to it, and as we know that the alkyl groups are actually the electron releasing groups, they are actually the electron releasing groups. So that means this alkyl group can release an electron, this can release an electron, this can release an electron, right. So more the alkyl groups, that means more the release of electron. More the release of electron means somehow its positive charge will get, some magnitude of its positive charge will somehow get neutralized, or you can say there will be more dispersal of charge, there will be more dispersal of charge, and that is why it corresponds to the stability. But as far as methyl group is concerned, it has no other you can say the alkyl group joined here. So that means there will be no electron releasing thing, and when there will be no electron releasing, there will be no dispersal of the charge. No dispersal of the charge, that means it will carry the good enough positive charge, and somehow it will make it unstable. So that is why the 3 degree one is stable and the methyl group is the least stable. The reason behind that is the alkyl groups that have been attached to it, right, because the alkyl groups are actually electron releasing, they show minus I effect. So that means they have the power to release electrons, and when they will release, they will somehow neutralize the positive charge, there will be more dispersal of charge, you can say, and there will be more stability, right. So this is how you can explain on the basis of inductive effect. Now if we try to explain on the basis of hyperconjugation, then to this carbon atom, how many alpha hydrogens are there? 3, 6 and 9. We have 3 alpha hydrogens. So that means how many hyperconjugative structures you will get? You will get the 9 hyperconjugative structures. And we know that when we get the 9 hyperconjugative structure, that means the more stability, right, because more dispersal of charge will be there then. So that means on the basis of hyperconjugation also, we have the 9 alpha hydrogens here, and here there is no alpha hydrogen, no hyperconjugative structure. So that means this 3 degree is the most stable. So now let's look at what is the another intermediate, carboanion, and the other is the carbene. and how they are actually, like what kind of carbanion or carbene are stable or not, and what are the factors that govern it. So just look at the board carefully.